Good day, guys. How are you? My name is Musa Talichani. The subject that I'm going to teach today is building and structural survey. And for the topic that we're going to talk about is calculating errors corrections. And then the first thing that we have to do, we're going to talk about the introduction before we start our subject. And then when we talk about the surveying, when we introduce them, we talk about the surveying involved measurement, distance, and angles and evaluations. The other one, we have errors occur in every survey measurement. And the other thing, understanding and correcting errors ensure accrued and liability of surveying data. These presentations are displayed in telepromote and present view wheel in the how to calculate the corrections. The types of the surveying errors, we have systematic errors caused by the equipment or environment, e.g. we have tape errors, and the other thing we have redeem errors, small unpredictable variations. And the other thing that we have blender by the surveying readings. This is our types of surveying errors. The other things, we have the causes of errors, which is we have what? Instrument, quality or uncapabilities, equipment, natural, temperature, wind or refractions. And the other things, we have human carelessness or poor observations. So now we have importance of errors corrections. Important corrections, we have improved accuracy of surveying result. Another thing, ensure structures or ability correctly. Help us avoid costly construction errors. Buildings confidence in surveying data. The other thing that we have, e.g. of error corrections, that gives the problems that when we use the tape, we have what? The problems of the compass surveying, errors, corrections, and included angles. We have closed traversy, and we have measurement inside, which is we're supposed to calculate is the measurement and errors. We have the common errors corrections, e.g. if you check, we have tape length corrections, and then the other thing, the formula they are given, we open the brackets, length minus L divided by L times the distance. We have what? The temperature corrections, CT equals to A, open the brackets, T minus T times the distance. And if you check here, we have tape. If you check, we have tape here, there is errors here. If you check on the tape, remember when they filled the temperature and the temperature at which the tape is made are not the same. Sometimes the tape is not adjusted, because if you check the tape, sometimes at the front there they have loses. If you check some here, sometimes we lost a measurement, which is sometimes we have short and standard, which is when we use the tape, you have to understand how to measure the tape and how to use the tape. The other things, we have another types of the corrections. We have slope corrections, and if you check the formulas, we have CS, which is correct slope equals to distance, and distance 2 minus the height distance. And we have pull attention corrections adjust for incorrect tapes attention. The other things we have sag corrections. That one we use when we calculate a weight applied when the tape sag, understanding the weight. E.g., we have the formula, which is weight squared and length cubic divided by 24 tensions squared. Is the formula that we use on the sag corrections. And then here we have examples of the calculations. We have what? Measurement distance, article types length, and nominal types length. We add the measurement distance, we have 100, and add the article tape length, we have 30,02 meters, and nominal tape length, we have 30,00 meters. And the tape length, we have the corrections. The corrections equals to 30,02 minus 0,00 divided by 30. And then we close the brackets times 100, which means the solutions that we have equals to 0,0667 meters. The corrected distance D equals to 100 plus 0,667 equals to 107 meters. And then the other thing, we have example there, the tape operator. We have measuring between points, and then we have the value R is recorded in the field and corrections. The other thing, we have T as calculated, we have setting out in value, we have TS now knowing as the corrections are completed. The other things, we have slope corrections from right triangle geometries. H, we have horizontal distance. S, we have S slope distance. V is a vertical distance, and theta we have vertical angles, and Z we have Zonon's angles. At the H, we have using the S as a cos, and then other thing we have sine as example that we are going to use it. The minimizing errors, as we said at the back, we have the calibrating instrument regularly, and we have measurement under suitable weather conditions, use proper techniques, e.g. tension, alignment, and double check all readings and calculations. And then we have maintain clear field. And then the other thing, we have tape corrections. When we talk about the tape corrections, we talk about deepening up on the occurrence required in taping. Certain corrections are made into the original measured distance. The major sources of the errors taping can be identified in the terms of the following corrections. The corrections for standard lengths, the corrections for sloping, the corrections of the tension due to alignment, the corrections for temperature, and also have sag corrections and corrections due to wind. Then we have the objectives in the module. The student should be able to understand linear measurement concept and apply the corrections to linear measurement errors. This is a thing that encourages the student to understand how to measure and how to correct the measurement from the tape. Sometimes you can measure, and sometimes when we use the tape, you have to assume. When we assume, we're supposed to use what? 100 millimeters to assume the tape if it's on the errors. Thank you.